All right. Hey, Guildies. Fletch here. So today we're going to talk about domain versus system. The idea of this talk is that there's different levels, scopes, as you zoom out about a system. And those levels are like, the code level. You write a line of code, you create a program, you create something that's deployable, you have a microservice, you have a subsystem, you have system, you have an enterprise, you have all these different levels that you can zoom into and zoom out of the code. So we're going to talk about like what those levels are called so that we can later on use those definitions for things that we talk about in the future. Oh, is there an echo going on? Jacques is saying there's an echo. Let me just double check so we don't get too far into this and record a completely echoed thing. And someone else please confirm also if you hear an echo so that I don't continue this whole thing on and make it really annoying. Okay. Yeah, in my feedback I'm not hearing an echo either, so I'm gonna continue on as I am right now without worrying about that too much, unless a lot of other people say there's also an echo for them. Okay, so domain versus system. We're going to jump into this part right here, the central code. This is this is the part that you usually think of when someone's going in and they're coding. They're writing a script or something like that. When we think of the code, we think of the low-level implementation, the stuff that the business logic, the domain layer, the BLL, the business logic layer, things like that. And when somebody's writing a script, a batch file, just some individually running JavaScript, or creating a dynamically linked library, a DLL, or a NuGet package that's just packaged up code, or Maven package possibly. These are just the code. So like the vast majority, when we're trying to solve a business need or the domain problem as we call it, this is the code. It's the domain. So for a lot of just coders and programmers and just general developers out there, this is essentially the end of the talk. This is one bit of code. If you work on SRE or infrastructure and you write scripts for things, that's just code. So there's like a chunk of code. A lot of times it's just the functional portion, but the functional portion could also connect up to writing to a file system or something like that, which I'll talk about in a second. But just this functional bit of code that does things that we need it to do. This is the domain, and the domain, in order to connect up to other things, has an imperative nature to it. So there's the functional nature to things, and there's an imperative nature to things, and I'll jump into a little bit more of that here in a minute. So this whole box with the big blue border and the red lines and everything like that, this big box represents a program. We'll just call it a program for right now, and the domain is one part of that program. So I just went ahead and minimized the domain here. So that I can have some space to talk about testing the domain specifically. So a lot of times you have like a whole other project, or maybe it's part of your build system. So it's part of the same. It's in the same hierarchy of folder structure or something like that. But you have your test module or your test project, and that test module does three different things technically. It provides inputs into the domain. So it gives inputs to the domain, calls things in the domain, and it creates these inputs programmatically. We're talking about a program here. We're talking about programming. So not exploratory testing or manual testing, a person going in and just making things up. This is programmatic inputs. They might have been generated, programmatically generated by a program the developer wrote, but these are inputs that go into the domain, and they're very predictable. And then the domain gives outputs back to that test module. So, it's calling this system under test, which is going to be part of the domain, and then the domain's going to give those outputs back, and those outputs are going to be validated. So the test module gives inputs, gets outputs, and then makes sure that those outputs are exactly what we expected to be, that the domain should be returning to us. So I'll just go ahead and minimize that down too, because we're going to fill this program box with a few different things. So anytime we see this little purple box, there's going to be a few later on. You've got the green giving inputs to the thing, and the blue taking outputs from the thing, and then internally it's validating those outputs. And just as a reminder, the feed is about 30 seconds behind, 20-30 seconds behind. So if you do ask a question, it'll be a second before I notice it. So we have this thing called the back boundary. This isn't to scale currently. I just had to minimize some things so that I could show you what the next thing is. So the back boundary is the things that the domain connects to at the very end. We call it the back boundary because usually, the domain is creating, let's say, a user. It does all the formatting of that stuff. And at the very back, at the very end, it calls a database to insert it. Or it saves it to a file. Or it does something like that. Not to say that you have to wait as the very last action in your programming to call the database, because sometimes you want to get some data from the database before you start processing. But we still call that the back boundary. It's stuff that sits on the back side of the domain. And these are things that are going to be, it's not a singular concept. The back boundary is anything that's reaching out to call the OS or to call something on the network or HTTP, something that the domain doesn't control. So the domain is going to be functional stuff that deals with our business needs, our domain model, our business layer, business logics, and the back boundary is the stuff that's going to end up reaching into stuff that we don't control. Our domain doesn't control the file system. It can write to the file system, it can read from the file system, it can write to a database, it can read from a database, but it doesn't control those things. Anytime it reaches outside of itself, there's a back boundary. So yeah, we have these red lines, which will come up a few times later on, represent things that go outside of our program, things that are going to end up needing resources that need to be disposed, HTTP resources or file system resources. So the back boundary has these red lines that go out of it. And then we have this yellow portion here. I'm just using this yellow portion to represent what we call the ACL, or the DTO portion. It's when we translate data objects between two different things, and we call it the ACL because it's the anti-corruption layer. Because the domain really cares about its domain models. But sometimes, in order to consume something on a back boundary, it needs to consume models from an SDK, or entities from a data layer, or something else. It needs to consume those, but we don't want to have to couple our domain to some third-party thing or some database. So this anti-corruption layer allows us to keep a non-corrupt domain, so the domain can work with whatever models it wants to work with and not have to worry about, if we update a NuGet or update something, pull in some new change to a third-party system. This anti-corruption layer allows us to focus that portion to translate between the models instead of having to change our entire domain. We want to decouple ourselves from these third-party or these things that we don't control, like the operating system and databases, things like that. So I'm going to go ahead and minimize that so I have some space to work with down here. So now we'll talk about the front boundary. So the domain and the back boundaries are libraries, not executables. So the domain, it builds into a DLL, dynamically linked library, or it can build into a NuGet package, which is a collection of DLLs that you can download essentially, or Maven package. And the back boundary, same thing. The back boundary is either already objects that you can pull into your system, that you can link into your system, or the back boundary might be part of the domain, just sort of separated out, and separation of concerns, it's kept separate. Either way, those things build, but they don't run. For the most part, you don't hit execute or run or double click a file and then the domain runs, for example. You have what's called the front boundary. And the front boundary serves essentially two different things. If it's not something that runs on command, then it's something that runs continuously. So it either is the thing that starts up and runs the program, or is the thing that receives input from external. So in the case of an API, the front boundary starts up and builds the API and does all sorts of registrations and security and cross-cutting concerns, and it exposes endpoints, API endpoints, all across the board. So you can have getters and setters, posts, puts, deletes, all this sort of APIs. So it allows you to have incoming data into the system. And then that data is then translated, cross-cutting concerns like authentication, authorization, logging, all those things are handled on the front boundary, and then the front boundary will, I'm going to go ahead and show the red lines here. So all these things coming in from outside the system that you don't control hitting your system, and then we have that ACL, that yellow portion right there. So the front boundary takes all this stuff from outside. They could be a parameter list from a console application, could be API inputs, could be just an HTTP call to a website, whatever the case is. and then there's this ACL where we translate from those DTOs, or view models in some cases we call them, or the DTO models, into the domain models. Because the domain is really the king of the system, and the front boundary is just, it's just the interface to the outside world, the way that you want people to call into your domain. You want to keep these two ideas separate. And this sort of changes things to show you what the scale of the system essentially is. So the front boundary should be a very thin layer on the front that does those cross-cutting concerns and takes in the requests from a console application, or the request to a website, or the request to an API, and does all the cross-cutting concerns, and then translates that over the yellow line up into the domain. The domain may not be bigger than the other parts of the system if you have a really small domain, but in level of importance, or in level of who's the king of the system, the domain. The domain is the one who is the master of the system. So essentially that's the size of the domain. And then the back boundary. The back boundary is just another implementation detail. It's not the king of the system. We have tests over there. Technically, the tests could be far bigger than the domain. Generally speaking, you could have a 10-to-1 ratio of tests to domain code, but then there's not enough space to really represent that here. But so you have the tests testing the domain. All right. So here I've changed. Let me just go back and forth a couple times so you can see really what that changes. I've changed the domain to show that you have the functional core and the imperative shell outside of the functional core that wraps the functional core. And I do this. It's very important because the imperative shell is the thing that is going to work with the back boundary, anything on the back boundary, anything that calls out externally. And the functional core is all of your algorithms and business logic that can be tested functionally. So that's why the tests are really just connected to the functional core part, but that's all wrapped by the imperative shell. So for example, if you have a method that it's given a user ID, and the first thing it does is it pulls a user from the database, and then the second thing it does is a bunch of functional stuff. Then what you would do is you take that functional stuff and put it inside of its own method, and then have your original interfacing method, is what I call it, the imperative method, do the thing where it calls the user, gets the user, and then call into that functional method. And then the functional method just uses that user and does all the things it has to do. But then when you come and test that, you really only test that functional part, but you mock out a user. You say, this is exactly the user I'm expecting to want to test with. You pass that user into the functional method does all the stuff, and then it returns the result, and you validate that result. So that's really the biggest important thing for separating the imperative shell from the functional core. This is just going to zoom out a little bit. So we still have the view of that whole program, but now we can see outside of the program where some of those red lines go. So that back boundary could hit file system stuff, it could hit database stuff, or it could hit just a website, because sometimes you just, you pull from a website. You parse out some of the data, you get whatever the case is. And there's any number of persistence that you could be doing. So from now on, though, as far as the back boundary is concerned, the back boundary that's directly tied to a domain, I'm essentially going to be focusing on it's a database. It's persistence. I'm not going to go into all the different ways that you can use persistence on all the different methods, but it's persistence. And now that I've focused in on that, I'm also going to show the red lines toward the bottom that the front boundary, from your direction, the front boundary, okay, touch it, goes out here to the cross-cutting concerns. I'm a little bit covering it a little bit, but that pinkish database is cross-cutting concerns. And so what those are is if your front boundary is taking requests and it's logging things, or it's doing authentication or authorization, it's reaching out to some other data system that it doesn't control to say, hey, log this, or hey, give me validate this key, or authorize this person, or whatever the case is. So the front boundary has its own form of reaching out to some other sort of data. And then we have the domain, and this plays in with that imperative shell being wrapped around there. The imperative shell, apart from calling just its own back boundary, also calls back boundary stuff that have its own ACLs, that have their own ACLs, to SDKs. So if you're doing something with shipping and you pull in the FedEx or UPS SDKs, and you're you're using those, and it's connecting to some system. And that system has its own persistence and data. It doesn't have to literally be a database. That's why it says SDK in there. But it's reaching out to an SDK to some other system that has its whole own system. And then you ACL it. You have this anti-corruption layer where you can make those calls, and then you can translate them into domain models, and then you can pass those domain models into your functional core to do functional stuff with it. You get that back. You pass stuff into your own database through the back boundary. The domain's back boundary isn't literally just for its own database. That's also anything that's reaching out that it doesn't control for SDKs and things like that. All right, so the truly owned back boundary is the DB context that the domain controls. So I've went ahead and moved that database from being the top to being right there on the side of the system. That's just so I can get some alignment later on. It's still considered the back boundary, but the domain's back boundary that it owns is the context of persistence that it owns. And the word context is very important because we get into this idea of bounded context, because this program has a bounded context. Everything related to the domain, the functional portions of the domain, is stuff where we're trying to solve a particular business problem, a domain problem. And so we have all the stuff to solve that, and we have the context directly related to that. For programs that are solving other domain problems, for example, some people will conflate payment methods with shipping, for example. If you have a shopping cart and you take payments and also you do shipping, those are two different contexts. Some people, you stuff that all into one thing, but those are two different contexts. And one of the things is going to be dealing with a database that has to do with payment information, and one of them is going to have to do with a system that's probably calling SDKs for UPS and FedEx or whatever the case is, and they have their ACLs for that. And those are two different concerns, two different contexts. I should stop saying concerns because that's a slightly different thing. But two different contexts that have their own context and databases. So here I'm just sort of making the arrow because I'm renaming some things here. I used to just say tests there. Now it says unit because it's actually unit tests. So I've named this test unit because I'm about to talk about some other forms of testing. So unit tests test the functionality that's controlled by the domain. So the unit tests are going to the functional core. It's testing all that functionality that defines the behavior and the business rules that have been agreed upon for the product. And the unit tests test all that stuff. And specifically, to put it in the way that I've written down in my notes, unit tests test the functionality controlled by the domain. I'm not going into all the things about unit tests. That's just one aspect of what a unit test is. But here I went ahead at the bottom and added integration tests. So integration tests, they test some part of a system with the understanding that the system may be reaching into things that it doesn't control. So the integration tests are going to be tested through the system, and with the understanding it may or may not, usually will be, otherwise there's no point of the system, it will be doing something that the domain doesn't control. In this case, it's going into the front boundary. There will be some cross-cutting concerns being hit. It'll be going through the imperative shell. It'll be hitting some SDKs from either some third-party SDKs or maybe an SDK for another program that you have running inside of your environment. It'll be possibly hitting the context that is owned by this domain, the contextual database. And so an integration test, it'll still be going through that functional core, but understanding that it's not being passed in some sort of mocked fake data. It's not being given a user that's just been made up in code by the developer. It's going to be going through also the imperative shell to get a real user, to do all the stuff in the functional core with real data going to the SDKs and things like that. So I also added integration up there in the top corner. So integration tests could also be directly hitting that back boundary. So let's say you have a back boundary with its own context that we call the repository layer or has a repository service. And that back boundary is essentially just focused on hitting a database, updating tables, pulling from tables, deleting rows, things like that. And the integration tests might also be, or might instead be, hitting that imperative shell. So it's still skipping the front boundary and it's not being called externally. These integration tests are compiled or built with the system, and then when the system's built, it runs the integration tests and actually goes through the imperative shell, hits those SDKs, hits the domain, functional core part of the domain, goes to the back boundary. So the integration tests are not just testing the functional core, If you're going through and hitting SDKs and hitting APIs and hitting other databases, that stuff that you don't control, those are integration tests. So that MyDB context, that yellow DB context up there, I'm going to go ahead and zoom in on that. It's obviously an oversimplified idea of a database because we're not talking about DBA or database related stuff here, but I'm going to go ahead and focus on that database for just a second. So some development includes writing scripts and code into functions, procedures, and more. So if you're in a database and you're writing scripts and functions and triggers and views and all this sort of stuff in a database, then those things are tightly coupled to data storage on the operating system with the database server. These things, whenever a database saves something in a table, it's saving it on the operating system. So I'm just going to put these little extra test things up here. These are the purple test colored boxes. So you can write unit tests against this directly in the database. And those unit tests are mainly going to be testing, just like I said before, inside of the functions, for example. So you write a function inside of a database, and that function is going to be, let's say it's a helper function. So all of your procedures, or some of your procedures and other parts of the database, they're pulling and they're inserting and updating and deleting and reading from the database. And then also during some of those stored procedures, they're calling some functions that are doing some sort of functional thing. If that's the case, then your functions are purely functional. Then you write tests against them. We can call them unit tests. And then integration tests, anything where you're writing your procedures and the code of the procedures or the functions are saving data to the operating system, which is something that you don't control. Same data to the operating system or whatever the case is, we're going to call those integration tests because they're not just testing your code, they're testing how your code works with the operating system. So this is just sort of like a a revelation of under the covers of a database and under the covers of the Chrome browser that I'm using right now, or under the covers of any program. It's the same thing as the program that I showed before. The program has a front boundary, and I'm sure whoever wrote the database server has written integration tests against it. The server has its own functional domain, and they've written unit tests against that. They have their back boundary for the database isn't going to be another database. Their back boundary is going to be how they save things to the operating system. It's going to be the same exact thing as any other program. So this is just the structure of a program in general. And we're going to take this structure of a program in general, and we're going to sort of minimize it into what we call a component. It's still a program. It has a contextual meaning that I'm calling it a component that I'll talk about here in a second, because it is a component of software. If you saw in one of my previous talks, I talked about how software isn't just a program. Software is multiple pieces of multiple programs working together. So we're just going to sort of minimize our program, and we're going to call it a component of software. So if you have multiple programs working together, this is one component of the software. So if I minimize it as a component, we're still going to see that the integration tests, externally speaking, are outside of the component, and they can test into the component. These are going to be like the integration tests that become regression tests, the ones that are going to be created and ran by QA or managed by your quality engineering team, and they're going to they're possibly going to be run once something is released or deployed somewhere. Then they're going to run these integration tests against it, automated regression testing, for example. And also the database context is an implementation detail. So a component doesn't have to have a database. A program doesn't have to have a database or its own context of persistence. It could be purely functional, or it could be a third-party wrapper just to wrap some sort of SDK calls. But possibly you have that context, which is external to the component, and possibly you have those integration tests external to the component, and that's just implementation details. So web application. A web application is an example of a component. So we have a web application. It could be React, could be Angular, could be Vue, could be anything that you want it to be. And it has a front boundary. It's the same exact thing. This looks like a copy-pasted version of everything that I said, because that's what it is. And you can see that the back boundary, instead of reaching directly into a database, it reaches into some sort of component. And that component calls other components. And there's components all over the place. It's components all the way down. But let's go ahead and rename some things so that we can imagine a web application with the same exact structure, but we're going to rename some things. So one of the things we do here, I'm going to bring my mouse over. The domain is what we're gonna label as JavaScript logic, services, application logic, validation. The big middle part of your web application, the biggest JavaScript part, is the domain. The wrapper portion of the domain is where we're going to have the caching, the storage services, the JavaScript storage, local storage, and things like that. We're going to have the controllers on the front side of the imperative shell. These controllers and the two-way HTML binding and things like that, just the things that directly connect to the HTML. The HTML is the front boundary. That is, whenever somebody makes a call, it directly hits HTML. HTML is the front boundary. It receives everything. And then, I don't know if you know or know, but whenever you compile up some sort of JavaScript application, then it makes the HTML. At the very top, it says script, main.js or something like that. Script. Maybe it's just a small wrapper of HTML that gets filled in dynamically. But that HTML is the front boundary. It decides which modules we're going to load, which JavaScript modules we're going to load. Then that reaches back into the controllers, and then there's a whole bunch of domain stuff. And then there's the caching and the storage services that it's going to interact with, and it's going to connect up with this ACL, anti-corruption layer, to the HTTP services. So in your JavaScript, you're going to have some sort of HTTP service that defines the API endpoints that you want to be calling, and it's going to call up those API endpoints. And that's what we're going to call possibly a gateway. I mean, you could be calling microservices directly, or you might be calling a gateway microservice, which will then be sharing out or farming out the calls to some other services as necessary. We're going to say these unit tests are possibly in Jasmine. We're going to say we're using Protractor for some of the integration tests. And then we've got like Selenium, external to the program, not tests that are written into the program that run at build time, but external to the program. We've got these integration tests that are going to run Selenium or something like that. And they're going to be calling into a running version of the website in order to do actual integration tests for the whole website. So same exact thing, but let's go over like for a microservice, what a microservice looks like. So the same thing with the microservice. We've got the domain, we've got the imperative shell, the functional core, and then we have the API and the related cross-cutting concerns, which, like I said before, logging and authentication, things like that. So for our integration test of this system, we're going to use Postman or Playwright or something like that. These integration tests are going to run against an actual running system. We've got someone calling into our API endpoint like a web application. Like we just said, that web application calls into API endpoints, so gateways or microservices. So web application is a component of our system, and the web application component calls into this little star right here for people in future reference, the little yellow stars that I put on these things. That means like the initiator of the call. So data can flow both ways, but the initiator of these calls is the web application calling into the API. You could have a bus. So here's a new icon on here. This purple square box is like a bus. So a bus could be a message queue, a pub sub, an ESB, whatever you want to say. That something that's automated or not another component directly calling in, but some sort of a bus or a queue that could be calling into these API endpoints. So we've got buses initiating the call and calling in. This arrow just says it's passing data to the API endpoint. You've got other microservices that use the SDK of this microservice. So this microservice has its own SDK that represents calling into the API. And these other microservices call the SDK to pull data from the system. This is specifically a one-way thing. It's just to pull data. You should not be using SDKs to say, go update something, not within your own system anyway. You shouldn't be using SDKs to say, go update something. You should be using something like buses. We're going to say XUnit for our unit tests, testing against the functional core of the domain. And we're going to say that this API can send information to the domain, it can receive information to the domain, and then maybe at the tail end of that, it sends it off to a bus. So if it came in from a bus, and then it calls all of the bounded context of this service, and it gets back to the bus, it gets back to the API, then it maybe sends to the next bus, or sends a message, I did a thing, and then the bus knows who subscribes to that, or whatever the case is, I did a thing. And then we call it data repositories for the back end, the back boundary, and we call it a context for a database. So that's all sort of like just a renaming of those same core concepts as a microservice. So we're going to zoom out again. So we've got these components, and these components, maybe one of them up higher, or this first one could be a website, or maybe these are microservices, or maybe these are gateways, or whatever the case is. So let's say in this case we have a bus, and that bus had something put on the queue from some other service we don't see on here, or a person added something manually to the queue, whatever the case. So the bus sends something to the component does some sort of updates with its own context, its own database, and then that sends something to a bus. Two things subscribe to that, so the bus here. This one with this yellow arrow is like that SDK call back here for these yellow arrows. So this component, it gets something from the bus, it pulls something from this other component over here, and eventually, it goes through all these things and it comes out and it ends with another bus call. Or it could end with some sort of an update to a system, and then the website, for example, could be checking for updates to that system at this level, at this component. It could be calling into this component saying, I sent you some payment information, I sent you some, or actually here's a really good example. So here's the path of the payment information, here's the path of the shipping information. Once those things get all the way through all their components, this thing subscribes to both of them and it watches for both of them. Once it receives both of them, then it says, okay, we're going to place the order. So maybe this is the order microservice. This isn't like literally for a system, but this is the order microservice. So when the website places the order, way back wherever that is, it's then pinging this thing for the database. Be like, hey, for this order, let me know when it's done, let me know when it's done, let me know when it's done. And then eventually it says, hey, your order's been placed. So it takes all of 3 seconds or whatever the case. So it goes through all these things, takes all of 3 seconds, and then the order microservice can then say it's placed. Or it passes on to another bus and it continues on. So I'm going to zoom out a little bit. I'm not going to zoom out yet, but I'm going to show that this is what we're going to call system testing. So this is a system of components. And the word system meaning, multiple pieces working together. So system testing is, instead of it pulling from a bus or being pushed to from a bus and then pushing to a bus over here, we're going to instead say we're going to call the API endpoint with this postman test or playwright test or whatever. And we're going to give it the data that we want to test with. It's going to go through all the system, and we're going to be doing the same thing that the website was doing. We're going to be pinging the component over here, waiting for the data, and then once that result gets into that component, we're going to take that as an output of the system, which comes into our test, and we're going to validate against it. So system testing, this is a system. You have multiple components working together. Let's go ahead and zoom out one more layer, and we can see this layer. So now, instead of that being called a system, we're going to call that a subsystem. So I've just sort of zoomed that out into this subsystem A over here. So we're going to call that a subsystem because even though that's one cohesive bunch of services, of components that work together, we're going to say it's a subsystem because really that subsystem can have its own logical system testing against it. And so we're going to call that a subsystem of the system. So as sort of a closing note to this idea, an environment, when you hear about an environment, you hear like the test environment or the production environment or the developer environment. So you have these environments, and that means that every component in a system within that environment, and this is like a whole system here, every component inside the system can only work with other components in the same exact environment. So if this is the production environment, these only work with things in the production environment. If this is the QA environment, you would never have this component here calling into a bus in the production environment, for example. And same thing the other way around. This was the production environment. You wouldn't have a component in the production environment sending data to the test 2 environment, for example. So they only work within their own environment. On the other hand, if you have a test system, you have a test environment and you're working in a test environment, but there's some other system, either in your company, maybe a different org chart part of your company or something like that deals with a different system of your company. Or let's say that the other system is FedEx, since we're going to stay on that track. So FedEx has its own system. You're working in your test environment. Your test environment can reach into the production environment of other systems. They're systems separate from you. For example, you can reach into the FedEx production system. Now, you might think you're reaching into the FedEx test system, but you're not, because they give you a test account, all that sort of stuff. That's their production environment, and they create you a user called test, and they have something like feature gating or authorization types that change the way it functions for you. but you're not reaching into their test environment or their developer environment or anything like that, or their QA environment. Whenever you're in your test environment and you're reaching to some other systems environments, it's always their production environment. Even if it's called, a test user or something like that, it's their production environment, a test user on their production environment. And that's all the levels of a system. So starting from the very low level of code, you've got the domain, you've got a component, which is a bounded context that only deals with itself. I did not say anything about separation of concerns, but something like, in this case, you have the web application as one concern, the API is a concern, the domain is a concern, the repository is a concern. This is a vertical separation. The website, and you can even say the HTML and CSS is a different concern. That's one concern. The design, even the UX, maybe some UX integration, and then the JavaScript. Back one more, and then all the JavaScript stuff, including like the HTTP services. Those are different concerns. So that's separation of concerns. And not dealing with cross-cutting concerns, but separation of concerns is web application, API, domain, data repositories, database, and then bounded context is a horizontal thing. So this grouping right here that I'm looking at has its own context. So there we go. Talked about those things.